This is the second talk of a three-part series about neonatal EEG. It is intended for the Nicklaus Children's Hospital Neurophysiology Fellows. This talk will have two parts. The first part will be conducted in a conversational format, and the second part in a question and answer format. In it, I will address graphoelements. I'd like to start this talk, as I did in our previous talk about neonatal EEG, by showing you this figure. I do so to emphasize the significant changes that occurred in the neonatal brain from 21 to 40 weeks conceptual age. These changes are reflected in the EEG age-specific background patterns and in the appearance and disappearance of age-specific discrete waveforms called graphoelements. Graphoelements will be considered from the point of view of their scalp location. During this talk, location will be pivotal for their classification. So we will talk about frontal, central, temporal, occipital, and generalized graphoelements. The second parameter we shall consider is chronology. Chronology will be given in conceptual age. This refers to the time from the first day of the last menstruation until the EEG is done and is, as we will use it, equivalent to postmenstrual age. After chronology, we will consider the relation between the different graphoelements and the EEG background. Recall that during early fetal life, up until about 30 weeks conceptual age, all normal background EEG activity is characterized by tracé discontinue. It is discontinuous pattern with low interburst amplitude. Between 30 and 36 weeks, we also find tracé discontinue. The interburst amplitude during this time is slightly higher. And also during this time, a continuous pattern appeared that is called mixed voltage activity. After 36 weeks, we find different patterns. We find tracé alternant and three continuous patterns, which are high voltage slow, low voltage irregular, and tracé Maillon. In addition to the relation between background and graphoelements, we will consider the relation between specific behavioral stages and graphoelements. The behavioral stages are those that we alluded in the prior video regarding neonatal EEG. The behavioral stages include active and quiet awake, active sleep, quiet sleep, indeterminate sleep, and transitional sleep. As you recall, the amount of active, quiet, and indeterminate sleep is linked to conceptual age. The last parameter to consider regarding graphoelement is morphology. And a good place to start talking about morphology is definition. And a good definition to start talking about morphology is spike. A spike is defined for some neurophysiologists different in the neonatal period than in older individuals. A spike is considered by some a sharp-looking wave that stands from the background and lasts less than 100 milliseconds. Yet other neurophysiologists adhere to the classic definition of a spike. They define a spike as a sharp-looking wave lasting 20 to 70 milliseconds and find no reason to modify this term when referring to neonates. Another term we will be referring to often in this talk is sharp wave. For some authors, sharp wave consists of sharp-looking wave lasting between 100 and 200 milliseconds. Yet other authors define sharp wave as consisting of a sharp-looking wave lasting between 70 and 200 milliseconds. The term sharp transient is used by some electroencephalographers to refer to a spike or a sharp wave with no obvious pathological significance. Discharges imply waves with less than 3 phases or lasting less than 0.5 seconds. Bursts are waves that last more than 0.5 seconds and have at least 4 phases. Hence, the distinction between burst and discharge is made by initially considering duration. A wave lasting 0.5 seconds or less is considered a discharge regardless of the number of phases. When an element lasts longer than 0.5 seconds, it is the number of phases that determine if it will be called a discharge or a burst. Those with 3 phases or less are called discharges. Those with 4 phases or more are called bursts. The term encoches was borrowed from the French, and it is a shame that we have not given it back. In English, the best translation I could find was notch, and in Spanish, muesca or marca. Encoches refer to a broad diphasic transient with a frontal initial negative deflection followed by a large positive deflection. So how will we put it all together? We will start with location. Then I will introduce a rectangle where conceptual age will be represented in weeks. And I will populate the rectangle by adding a structure extending from the time the graphoelement first is encountered, that is its debut, and the time the graphoelement is no longer present. The intensity, that is the relative amount of a given graphoelement per period, will be represented at different conceptual age by the width of the structure. This will become apparent to you in the next few frames. Over the left side of the rectangle, I will add the EEG background pattern when those elements tend to occur, and when appropriate, I will add the behavior state during which the graphoelements are most often found. And finally, I will talk about specific morphological characteristics of the individual graphoelement. I will use this table to organize this talk and to guide our approach to graphoelements. This table looks difficult to understand, but as I hope you will come to realize as this talk progresses, it is not. On the left top corner, there is a cell with the word graphoelements and conceptual age in weeks. Graphoelements are arranged in the column below. They are grouped according to their most prominent localization. So we will be talking about graphoelements that occurred in the frontal region, which include frontal sharp transients and anterior delta runs. Those in the central region, which include Rolandic dips, Rolandic sharps, and delta brooches. Those that occur in the temporal region, which include small temporal positive waves, theta and alpha temporal sawtooth sharps, temporal rhythmic 3 Hz activity, and temporal negative sharps. Those in the occipital region include occipital theta and delta negative sharps, as well as occipital delta, brief occipital theta burst, and delta brooches. And those with a generalized distribution include post-stimulus depression that manifests by transient flattening of the background activity and generalized theta activity. The second item in the left top corner cell is conceptual age in weeks. Remember, throughout this talk, all ages will be given in conceptual weeks unless they are mentioned otherwise. The weeks are listed in the same row, separated into cells of 2 to 3 weeks each. Below each of these cells, the number of crosses indicate the frequency of a given graphoelement at a particular week period. The little cross symbol indicates that the recognition of the graphoelement preceding it is particularly important not to overdiagnose epileptiform activity. The asterisks indicate that the graphoelement preceding it can be used to age the EEG. This concludes the conversational part of this talk. The second part of this talk, as we mentioned, will be conducted in a question and answer format. Here goes the first question. Frontal sharp activity predominates between 22 and 28 weeks conceptual age. A true, B false. The graphoelements located to the anterior region of the brain are those that we're going to consider first. They are called frontal sharp transients and anterior delta runs. Together, they can be called frontal sharp activity. Frontal sharp activity increases from about 24 weeks to about 40 weeks. And then they decrease, and by 48 weeks, they're usually gone. This activity is usually seen during a background consistent with tracea discontinue, mixed voltage activity, tracea alternate, and activity mayon. I will in the future often refer to these background patterns by their short name, as you see in this frame. So overall, frontal activity increases with conceptual age until term, declines during the first 3 to 5 weeks after birth in full terms, and is usually gone by 8 weeks of postnatal life in full terms. So the answer to this question is false. Next question. Which of the following is not true regarding very immature frontal sharp transients? A. Consist of single or polyfrontal spikes. B. The highest wave must be less than 100 microvolts. C. They should be gone by 38 weeks. D. They can be unilateral, and if bilateral, asymmetrical. In this table, you can see that the first highlighted element is FST, standing for frontal sharp transients very immature. Recognizing this pattern is important as not to confuse it with epileptiform activity. Very immature frontal sharp transients have their debut little before 24 weeks, are maximal by 26 weeks, and usually gone by 33 weeks. They arise from tracea discontinue, very immature frontal sharp transients have two varieties. One that consists of polyspikes with a crescendo quality, the tallest of the wave reaching an amplitude above 100 microvolts, followed by a slower wave. And a second variety characterized by a single spike followed by a slower wave. In the later variety, the fast wave extends clearly from the background activity and may have an amplitude of over 100 microvolts. Very immature frontal sharp waves may be unilateral or bilateral, but when bilateral, they tend to be asynchronous and also asymmetrical. So the answer to this question is B. Next question. Which of the following is not true regarding immature frontal sharp transients? A. Consist of a small single frontal spike followed by a slow wave. B. They can be unilateral or, if bilateral, asymmetrical. C. They should be gone by 38 weeks. D. They usually occur with a frequency of 2 per minute. In addition to very immature frontal sharp transients, we can also find in the premature neonatal EEG in the frontal region immature frontal sharp transients. The difference that the previous one were called very immature and these are called just immature. Their recognition is important as not to confuse them with epileptiform activity. Immature frontal sharp transients are first seen at about 29 weeks and increase in frequency up to 32 weeks. Then they begin to decline and are usually gone by 36 conceptual age weeks. They arise from tracee discontinue and mixed voltage activity, frontal sharp transients. The immature type is quite different from the two varieties of very immature frontal sharp transient we described previously. The difference between immature frontal sharp transients and the polyspike variety of very immature frontal sharp transients can be appreciated in this frame by contrasting the frontal sharp transients immature type in white with the polyspike variety in gray. The difference between immature frontal sharp transients and single spike variety of very immature frontal sharp transient can be appreciated in the same fashion. The main difference from very immature to immature frontal sharp transients is the disappearance of the polyspike when comparing it with the polyspike variety of very immature frontal waves, or the reduction in size of the single spike in the single spike very immature frontal sharp transient variety. Immature frontal sharp transients occur with a frequency of 1 every 2 minutes in healthy neonates. They are either unilateral or bilateral asynchronous and asymmetrical. So the answer to this question is D. Next question. Which of the following is not true regarding frontal encoches? A. Presence from 36 and 45 conceptual age indicates good prognosis. B. Most prominent during the first transition between active and quiet sleep. C. They are synchronous and symmetrical. D. The presence after 48-week conceptual age indicates a good prognosis. After reviewing immature frontal sharp transients, next in line are encoches. These graphoelements have received much attention during the years. They are a valuable finding to establish brain age. They are also a sign of a healthy brain when present at the appropriate time, and seldom are mistaken for interictal epileptiform activity. Not all agree as to their chronology. In Journal of Clinical Neurophysiology, encoches frontalis are described as being first sighted at 34 weeks, becoming maximal by 42 weeks, then declining quickly and disappearing altogether by 44 weeks. They arise from an ongoing mixed voltage activity before 36 weeks, and after 36 weeks, they arise from a background characterized by activité mayon, low voltage irregular, and tracee alternate. Yet other authors have given encoches a slight different chronology and background association. These authors describe encoches debut to occur at about 36 weeks, becoming progressively more frequent until 44 weeks, and then declining and disappearing by 48 weeks. These authors describe encoches as arising from activity myoin, low voltage irregular, and tracé alternate. The morphology of encoches consists of a biphasic wave. This morphology is rather different, as you can see, from the morphology of the immature frontal sharp waves. I have introduced the appearance of immature frontal sharp waves in gray. Encoches are bilateral, synchronous, and symmetrical. When present, they indicate good prognosis between 36 to 45 weeks. Also, their absence beyond 48 weeks is a sign of good prognosis, and therefore their presence after 48 weeks is a sign of bad prognosis. I have presented and explained this figure to you in part 1 of neonatal EEG. The reason I am showing it to you now is because encoches are specifically prominent during transitional sleep, specifically during the first sleep cycle, when active sleep becomes quiet sleep and the prevalent background activity is activité myoin. So the answer to this question is D. Next question. Which of the following is not true regarding anterior delta runs? A. They are frequent at 38 weeks conceptual age. They are more frequent during high voltage slow pattern. They are synchronous and symmetrical. And D. They are also called anterior slow dysrhythmia. In this table, we can see that just below encoches frontalis, we find anterior delta runs. Anterior delta runs are useful to determine brain age, but also it is important to recognize them as not to confuse them with ictal EEG activity. Anterior delta runs, according to some, first appeared at 32 weeks, increasing in frequency until 39 weeks. Then by 44 weeks they disappear. Other electroencephalographers describe a different chronology. They describe the debut of this wave at 37 weeks, increasing frequency up to 40 weeks, and disappearing by 43 weeks. Yet a third group of authors, while keeping the debut at 37 weeks and their peak at 40 weeks, these authors describe a much slower rate of disappearance, amounting to a longer presence. Yet they are only present, even for these authors, up to 48 weeks. So, incorporating these three descriptions regarding chronology, we can say that they may be present since 32 weeks and that anterior delta runs have to be gone by 48 weeks. Anterior delta runs are found during tracé discontinue, during mixed voltage pattern, during activity Mayon, and during tracé alternate. The morphology of anterior delta runs is very much like an EMG positive wave. It looks significantly different from encoches, here represented in gray, and anterior delta waves are synchronous and symmetrical. Other names used to refer to anterior delta runs include rhythmic bifrontal delta activity and anterior slow dysrhythmia. So the answer to this question is B. Next question. Frontal activity during neonatal period loses their sharpness. A true, B false. Again, I'm presenting you the table with all graphoelements. We have just reviewed the significant evolutionary changes that occurred in the anterior frontal region. As a whole, the evolution of the frontal region starts with very immature frontal sharps with the morphology that you can see in this frame, and the chronology that is shown above. Morphologically, there will be a drop in the size of the initial sharp wave as weeks go by, thus evolving into the immature frontal sharp activity. This activity will go further change, and that change consists of an initial increase in amplitude of the first part of the activity with decrease in amplitude of the following components of the element. You can see also their evolution by looking at the rectangle where the chronology is presented. These changes lead to the appearance of encoches, which then are further modified to become or be associated with frontal delta runs. So in this frame, you can better see than what I have just described to you the changes that go on from very immature frontal sharp wave to anterior delta runs, and at the same time, if you look at the rectangle, you can see their evolution regarding chronology. Please take a few seconds or minutes to look at this frame so you get an idea of the evolutionary pattern that goes on in the frontal region of the neonatal brain. So the answer to this question is true. Next question. Encoches frontalis and anterior dysrhythmia only occur as single waves. A true, B false. This epoch belongs to a 37-week conceptional age newborn. The arrow in this frame points to the typical single encoche frontalis. Here it points to a single anterior delta run. Here in this frame we can see two consecutive delta waves, likely representing slow anterior delta runs. So the answer to this question is B. Next question. Encoches frontalis rise is steeper than its fall. A true, B false. In this frame you can see the arrow pointing to a buildup of wave leading to a clear encoches. In this frame I have placed a box around the encoches frontalis, which I have enlarged to show you some of the characteristics of the encoches. These characteristics are a relative slow negative rise from the baseline as viewed from the prefrontal electrodes, followed by a fast drop positive deviation that crosses the midline. This is followed by a second low amplitude negative wave. The answer to this question is B. Next question. Which of the following wave characteristics do not suggest encoches? A. An initial negative component higher than the positive one. B. An asymmetrical pattern. C. A frequency of 2 per minute. D. All of the above. This is a cartoonish representation of an encoche. It is being viewed from the perspective of a frontal electrode. As you can see, encoches have 3 waves. The first wave is negative. This is followed by a positive wave, and then a second negative wave. The peak-to-peak amplitude ranges from 50 to 100 microvolts, and the duration ranges from 500 to 750 milliseconds. It is possible to distinguish encoches from frontal sharp activity with potential epileptogenic implications. Encoches that by definition are normal has a first negative wave that is usually shorter than the following positive wave. On the other hand, the first negative wave of an abnormal biphasic frontal wave is larger than the subsequent positive wave. Encoches are synchronous. Abnormal biphasic frontal activity is usually asynchronous. Encoches are symmetrical. Abnormal frontal sharp activity is usually asymmetrical. Encoches are bilateral. Abnormal sharp frontal activity is usually unilateral. Encoches are gone by 48 weeks. Abnormal frontal sharp activity persists after 48 weeks. Encoches occurred with a frequency of 1 or less than 1 every 2 minutes. Abnormal sharp activity occurs significantly more frequent. So the answer to this question is D. Next question. Which of the following graphoelements is less likely to be found in the central region? A. Rolandic dips, B. Rolandic sharps, C. Delta brushes, active sleep, D. Delta brushes, quiet sleep. In the central region, as you can see in the general table, you can find three elements: Rolandic dips, Rolandic sharps, and delta brushes. Delta brushes are more frequent during active sleep. So the answer to this question is D. Next question. Which of the following graphoelement is the first to appear in the central region? A. Rolandic dips, B. Rolandic sharps, C. Delta brushes, active sleep, D. encoches. The first graphoelement that appears in the central region is called Rolandic dips. Their recognition is important not to confuse them with epileptiform discharges. Their debut is just before 24 weeks, increasing in frequency up to 29 weeks. This frequently is sustained up to about 33 weeks and then declines and is gone by 37 to 38 weeks. Rolandic dips are present during tracé discontinue, during mixed voltage activity, and during tracé alternate. Rolandic dips consist of a run of 10 to 25 microvolts activity with a relative wide base but maintaining an undulating pattern. They often occur in the interburst period leading to a burst. The activity is negative in the central electrodes. The frequency of the dips is within the theta range or in the delta range. The runs last for about 1 to 3 seconds. The activity tends to be bilateral but asynchronous, and much less often it is bilateral and synchronous. It is usually symmetrical, whether synchronous or asynchronous. So the answer to this question is A. Next question. Which of the following central graphoelements is used to age an EEG? A. Rolandic dips, B. Rolandic sharps, C. Delta brushes, active sleep, D. encoches. As you can see in this general table, in addition to Rolandic dips, you will find Rolandic sharps in the central region. This activity can mimic epileptiform activity and should be identified to be able to determine their non-epileptic nature. Rolandic sharps have their debut by 26 to 27 weeks and increase in frequency up to about 32 weeks. Their frequency is sustained up to about 35 weeks and then decline. Rolandic sharps are usually gone by 40 weeks. As with Rolandic dips, they are present during tracé discontinue, mixed voltage activity, and tracé alternate. The waveform consists of sharp activity with an amplitude of 50 to 75 microvolts. They are often unilateral, at times bilateral but asynchronous, and rarely synchronous. The third grapho element occurring in the central region is central delta brooches. Delta brooches are used to age an EEG. Central delta brooches are first seen about 27 weeks. Their frequency increases up to 32 weeks and then decline and are gone by 36 weeks. They appear against a background characterized by tracé discontinue and mixed voltage activity. They are reported to be prevalent during active sleep. The wave morphology varies, but the basic structure is a slow delta wave with superimposed faster activity, often referred to as ripples. At times, the ripples are at the end of the delta wave. At times, the ripple occupies the whole slow wave, and at times, the ripples are confined to the beginning of the slow wave. The frequency of the fast activity, that is of the activity within the ripple, is 18 to 22 Hertz, and the amplitude of this activity is less than 75 microvolts. The delta activity is usually in the 0.5 to 1 Hertz range, and the amplitude ranges from 50 to 250 microvolts. Central delta approaches may be unilateral or bilateral. When bilateral, they may be synchronous or asynchronous. So the answer to this question is C. Next question. Small temporal positive waves have the same temporal profile as A. Temporal negative waves, B. Temporal sawtooth sharp theta, C. Temporal sawtooth sharp alpha, D. encoches. Temporal graphoelements include small temporal positive waves, temporal sawtooth sharps in the theta and the alpha range, temporal rhythmic 3 Hz activity, and temporal negative sharps. Recognition of a small temporal positive wave is important not to overdiagnose interictal epileptiform activity. Small positive temporal waves are first seen at about 24 weeks, and their density increases up to 30 weeks. After they decline and disappear by about 33 weeks. They occurred against tracé discontinue. Primarily, this activity usually occurs in runs of about 1 to 2 seconds, and it is positive at the temporal electrode. They have a small voltage range that goes from 10 to 25 microvolts. The frequency of the wave within the run is in the theta range or in the delta range. It presents no evolution, that is, no change in frequency or amplitude during the run. The activity is usually unilateral, but it may be bilaterally asynchronous or synchronous. Also, in the same region and at the same time, we see small temporal positive waves. We also encounter theta temporal sawtooth sharps. Theta temporal sawtooth are first seen at 24 weeks, increasing in density up to 30 weeks, then start declining, no longer being present at 33 weeks. They occurred against a background characterized by tracé discontinue. Sharp theta sawtooth waves usually occur in runs in the theta range. They are of medium amplitude, and as expected by their name, they have a sawtooth morphology. We may find them unilaterally, but up to 90% of the time they are bilateral, sometimes synchronous or asynchronous. So the answer to this question is A. Next question. Temporal sawtooth sharps alpha are most prominent at dash weeks conceptual age. A. 29 to 30, B. 31 to 33, C. 34 to 36, D. 24 to 26. Alpha temporal sawtooth sharps are helpful to age the EEG. Alpha temporal sawtooth sharps have their debut at 29 weeks, increase in density up to 33 weeks, then decline and disappear by about 35 weeks. They appear against a background characterized by tracé discontinue. They occur as a run very similar in duration as the previously described theta temporal waves, but the frequency of repetition of this wave are in the alpha range. The amplitude of these waves is between 25 and 50 microvolts, and obviously they have a sawtooth morphology. Temporal sawtooth alpha are usually unilateral and bilateral asynchronous. So the answer to this question is B. Next question. Temporal rhythmic 3 Hz activity is abnormal if present at 40 weeks conceptual age. A true, B false. Temporal rhythmic 3 Hz activity recognition is important as not to overdiagnose seizures. Temporal rhythmic 3 Hz activity has its debut at 27 weeks, increase in density till 30 weeks, and then decline, being gone by 33 weeks. It appears against a background characterized by tracé discontinue. They consist of runs of repetitive wave lasting for a few seconds, often presenting at the end of a burst with a frequency of 3 Hz per second. The activity is medium amplitude. This activity may be unilateral, bilateral asynchronous, or bilaterally, synchronous rarely. So the answer to this question is A. Next question. Temporal negative sharps are abnormal if A. Their duration exceeds 100 milliseconds. B. Their amplitude is less than 75 microvolts. C. Present at 40 weeks conceptual age. D. Present during quiet sleep. Recognition of temporal negative sharps is important not to overdiagnose interictal epileptiform activity. Temporal negative sharps have their debut at 27 weeks and increase in density up to about 31 weeks. This density is sustained till about 36 weeks. Then they start decreasing and are no longer present after 40 weeks. They arise against a trace discontinued background. They may appear as prominent waves within a run or rhythmic waves in the theta or alpha range, or as individual sharp waves arising from a relatively quiet background. The amplitude of the wave is between 25 and 100 microvolts. They may be unilateral or bilateral. If bilateral, they may be asynchronous or synchronous. Several features allow to distinguish temporal negative sharps from pathological sharp waves arising in the temporal lobe. The amplitude of temporal negative sharps is less than 75 microvolts, whereas the amplitude of pathological temporal wave is usually more than 75 microvolts. The duration of temporal negative sharps is less than 100 milliseconds, whereas the duration of pathological temporal waves is usually more than 100 milliseconds. Temporal negative sharps are monophasic or biphasic, whereas pathological temporal sharps waves are most often polyphasic. Temporal negative sharps are usually bilateral, whereas temporal waves that are pathological are usually unilateral. Temporal negative sharps occur during quiet sleep, whereas pathological temporal sharp activity tends to be more prominent during wakefulness. Temporary negative sharps occur with an interval longer than 1 minute, whereas pathological temporal sharp waves occurred with a frequency of more than 1 per minute. So the answer to this question is A. Next question. Occipital region is the most active region during 24 to 27 weeks conceptual age. A true, B false. Occipital graphoelements are most prominent graphoelements during extreme prematurity. They include occipital theta and delta negative sharps, occipital delta, brief occipital theta burst, and delta brooches. Occipital theta and delta negative sharps are most frequent graphoelements that present between 22 and 28 weeks. So the answer to this question is A. Next question. Which of the following activity is more likely to be present in a normal full-term neonate during the second week of life? A. Occipital delta negative sharps, B. Occipital theta negative sharps, C. Brief occipital theta burst, D. Delta brushes. As you can see in this table, occipital theta negative waves are a sign of extreme prematurity. They should not be confused with epileptiform activity. Occipital theta negative sharps are present at 22 to 23 weeks, decrease gradually, and no longer are seen at 33 to 34 weeks. They arise against a background characterized by tracea discontinue. They appear as 3 to 7 occipital negative sharp waves with a frequency in the theta range, and they tend to be unilateral, but you can also find them bilaterally, asynchronously, and bilaterally synchronous. In conjunction with occipital theta negative sharps, we often find occipital delta negative sharps. Occipital delta negative sharps have the same chronology as occipital theta negative sharps. They are present at 22 weeks and then decline, disappearing by 40 weeks. They arise against a tracea discontinue or an active myogen background. They occur in runs of several delta waves with a negative polarity at the occipital electrode. They can be unilateral, bilateral asynchronous, or bilateral synchronous. Another type of activity also encountered in the occipital region is occipital delta. This activity can be used to time the EEG. Occipital delta makes its debut at about 24 weeks, increases in density up to 30 weeks, and then declines and is usually gone by 33 weeks. It arises from tracea discontinue background and appears as undulating delta waves, maximal at the occipital region, often with superimposed faster activity. It is the undulating morphology that distinguishes this wave from occipital delta negative sharps. Occipital delta is usually bilateral, but not always synchronous. Another type of activity encountered in the occipital region is brief occipital theta burst. Unlike most occipital graphoelements, it occurs in full-term neonates. It is important to recognize this activity, not to confuse it with interictal epileptiform activity. Brief occipital theta burst have the debut at 36 weeks, increasing density till 44 weeks, then abruptly disappears. They occurred against a background consistent with an activity myon, and their morphology, that is the morphology of the burst, is often sinusoidal and at times having a spindle-like appearance. The waves within the burst are in the theta range. These bursts may be unilateral or bilateral. When bilateral, they may be synchronous or asynchronous. The last activity in the occipital region that I will refer to is occipital delta brushes. Occipital delta brushes are used to time the EEG. Occipital delta brushes make their debut by 30 weeks, increasing density up to 34 weeks. After this, the density remains constant till around 37 weeks and then declines, disappearing by about 40 weeks. They arise against tracea discontinuous background. Later, they appear during tracea alternate and during high voltage slow background. Delta brushes, that is occipital delta brushes, bear morphological similarities with central delta brushes because the brush at the time can be anterior, posterior, or compromise the whole delta wave. The frequency of the fast activity is less than 18 Hz, and the amplitude of the fast activity is less than 50 microvolts. The duration of the delta wave is between 0.5 to 1.5 seconds, and the amplitude is between 50 and 250 microvolts. Occipital delta brushes may be unilateral, but often are bilateral, synchronous, and at times asynchronous. So the answer to this question is C. Next question. Which of the following is not true regarding occipital delta brush? A. Most prominent during quiet sleep. B. Ripples are faster than in central delta brushes. C. Ripples have lower amplitude than central brushes ripple. D. Are less frequent than central delta brushes at 30 weeks. Delta brushes can occur in the central and in the occipital region. Central delta brushes debut earlier and disappear sooner than occipital delta brushes. Occipital delta brushes, here represented in blue, as you can see, have a longer existence than central delta brushes. Both central and occipital delta brushes tend to be gone by about 40 weeks of conceptional age. At times, in the past, due to the fact that they were gone by 40 weeks, the term ripples of prematurity was used. In this frame, I have introduced a chart with conceptional age in the x-axis and discharges per minute in the y-axis. The density of central delta brushes is represented in this figure. As you can see, its debut is about 27 weeks, maximal about 32 weeks, and are gone by 36 weeks. The ripples, as we previously mentioned, have a frequency of 18 to 22 Hz, and they are present mainly during active sleep. In this frame, I have represented similar parameters corresponding to occipital delta brushes. Their debut is a bit later. The frequency of the ripple is less than the frequency of the ripples in the central delta brushes. And as you can see, occipital delta brushes tend to occur during quiet sleep. I have placed this frame here to stress the difference between central and occipital delta brushes. Central delta brushes are earlier than occipital delta brushes. Most central delta brushes occur in active sleep. Most occipital delta brushes occur during quiet sleep. The ripples on top of the wave are faster in the central delta brushes than in the occipital delta brushes. The ripples of the central delta brushes have a higher amplitude than the ripples in the occipital delta brushes. So the answer to this question is B. Next question. Delta brushes during awake should disappear before delta brushes during active sleep. A true, B false. I hope you recognize the features in this frame. I have just mentioned them to you a second ago. In this new frame, I have added a curve to represent delta brushes during wakefulness. As you can see, delta brushes may also occur during wakefulness, but they are usually gone by 38 weeks. So the answer to this question is false. Next question. Transient flattening of the record in a neonate is most often a pathological finding. A true, B false. Generalized graphoelements include two very different patterns: post-stimulus depression and generalized rhythmic theta. Recognition of post-stimulus depression is important because it is often confused with seizures. This frame shows an example of transient flattening. Notice the flattening of the activity and that during the flattening there is muscle artifact starting shortly after the beginning of the flattening. This activity is first noted at about 36 weeks. It increased in frequency up until 40 weeks. It is maximal by then, that is by 40 weeks, and is usually gone by 48 weeks. They arise from activité maillon primarily, and it is especially prominent during the first transition between active sleep and quiet sleep. Some episodes are brief. The episode in this frame lasts about 4 seconds, but some other are much longer. This abstract, published in 1987, makes some relevant points that I will highlight for you. Transient flattening in the EEG of newborns usually lasts about 1 minute. Bilateral episodes are more common, but unilateral flattening can also be present. And most important of all is that they should not be misinterpreted as seizures. So the answer to this question is false. Next question. Generalized rhythmic theta is most prominent at weak conceptual age. A, 29 to 30, B, 31 to 33, C, 34 to 36, D, 24 to 26. Generalized rhythmic theta should be recognize in order not to confuse it with epileptiform activity. Generalized rhythmic theta has its debut at 27 weeks. Its density increases up to 30 weeks, and it is gone by 33 weeks. It arises against trasedis continuus. The activity consists of medium amplitude rhythmic theta waves with generalized distribution. The activity is bilateral, at times asynchronous and at times synchronous. So the answer to this question is A. Next question. Graphoelements start disappearing after conceptual age of dash weeks. A. 29 to 30. B. 31 to 33. C. 34 to 36. D. 24 to 26. I hope that by now you've seen this table enough to know it by heart. It establishes the reaction between graphoelements and their density in relation to conceptual age. I will, in the next few minutes, try to give you a panoramic sense of this evolution. This figure represents a head seen from above. The location indicated by the arrow will be the site of the number representing conceptual weeks. So, at 22 to 23 weeks, graphoelements are present in the occipital and frontal regions. The graphoelements in the occipital region consist of negative theta and delta sharps. Also, during this time, we find very immature frontal sharp waves. These activities are present, as we previously mentioned, between 22 and 23 weeks. Come weeks 24 to 26, Rolandic dips appear, coinciding with small positive temporal waves and theta temporal sawtooth waves. So, between 24 and 26 weeks, central and temporal regions become active. Still, in the occipital region, we find occipital theta and delta sharp wave, and we find very immature frontal sharp transients. Come 27 to 28 weeks, we find that generalized rhythmic theta is at times present. In addition, we also find temporal rhythmic 3 Hz activity and temporal negative sharps. In the central region, in addition to the Rolandic dips that were previously present, now we see Rolandic sharps. And central delta brushes. Going back to the occipital region, also during this period, we encounter the graphoelements we label as occipital delta. So as you can see, at 27 to 28 weeks, the neonatal EEG is very crowded with graphoelements in every brain region. Come 29 to 30 weeks, and we find more graphoelements. These new graphoelements are immature frontal sharp waves that tend to have lower amplitude than the one that were previously present. We also see alpha temporal sawtooth waves, and in the occipital region we find occipital delta brushes. So as you can see, at 29 to 30 weeks, the EEG is even more crowded than before. Then comes 31 to 33 weeks. At 31 to 33 weeks, generalized rhythmic theta disappears. This is the first graphoelement that disappears, and it occurs between 31 to 33 conceptual age weeks. Come 34 to 35 weeks, and at 34 to 35 weeks, very immature frontal sharp waves disappear. Temporal theta sawtooth waves disappear, and alpha temporal sawtooth waves become very prominent. Rhythmic 3 Hz activity disappears. Occipital negative theta sharps disappears, and about the same time occipital delta activity also disappears. In addition, small temporal positive sharps also disappear. And in the frontal region, encoches frontales appear. Overall, at 34 to 35 weeks, significant clearing of the neonatal EEG has taken place. Come 36 to 37 weeks. At 36 to 37 weeks, 3 graphoelements appear. In the frontal region, we find slow anterior dysrhythmia or anterior delta runs. In the occipital region, brief occipital theta bursts appear, and the third graphoelement to appear is post-stimulus depression. Also during this period, central delta brushes disappear. Alpha temporal sawtooth waves disappear. It is at 36 to 37 weeks that for the first time awake and asleep can be distinguished based on EEG appearance. Now comes 38 to 40 weeks and immature frontal sharp transients disappear. Rolandic dips disappear. And occipital negative delta sharps disappears. I also like to highlight that the delta broaches during awake should no longer be present after 38 to 39 weeks. So the EEG of a 38 to 40 weeks looks rather uncluttered, especially compared to how we look back at 28 weeks. Come 41 to 44 weeks, Rolandic sharps disappear, theta negative sharp waves disappear, occipital delta broaches also disappear. And as the neonatal period ends, only the few graphoelements represented in this figure are present, and usually by 48 weeks they are all gone. So the answer to this question is B. Thank you very much for your attention.